Right. So when you talk about circles, there's really two worlds you have to look at. There's the world of angles, and there's the world of lengths and segments. So let's just talk about just the angle formulas and the ideas about angles. So if I have a circle and there's the center, if we start with just the most basic one, if this is 40 degrees on the circle for the arc, the central angle inside is going to be worth how much?
Half of 40?
No,
Right.
no, exactly equal to 40. The central angle will always be the same measurement. I guess it sort of makes sense if you take a look at another circle, and you just take a look at maybe a quarter of it. How many degrees is that worth? 90. And if you're traveling on the circle, how much of a twist did you do? You did a 90-degree twist. So those are identical to each other.
All right.
The one you were thinking of was the inscribed angle. So when the angle is actually touching, the tip of the angle or the vertex of the angle is actually touching the circle,
Okay.
then that angle is going to be half as much as this one. So if this was worth 100 degrees,
It would be worth 50.
then that would be worth 50. And then there's two more pictures that are similar to that. If I had an angle like this, where if you take a look at this one here, this is made up of two chords. If I have it made up of a chord and a tangent, you could still use the same idea of being half as much, but you'd have to know this much. So if that was 200 degrees,
So it would be 100?
it'd be 100 right in here. And sometimes they like to play games with you. They like to tell you, they'll tell you that this much is worth 160. So you'd have to know to take 360 degrees, and you've got 160 there on the arc. So it would be worth just 200 here to complete the full 360, and then to find the angle.
Full circle is at 360?
Yeah.
And half of it, it's 180?
180, and that gets used a lot of times in kind of sneaky ways too, so that would be worth 100.
All right.
So that's the opening ideas with the angles. And there's ideas with the angles that you should know. One of them is with this picture, where you got two chords intersecting inside the circle. And if you're looking for this angle here, there's a way to figure it out. To figure out that angle, what you'd need is you need to know these two blue arcs. If you know the blue arcs, you could figure out the vertical angles inside. Do you remember the formula for those vertical angles inside?
Nope.
It's the average of the two blue ones. So to find an average, you take the two numbers, the two arcs, and add them together. That says arc plus arc divided by 2.
Remember now.
So to find, if I want to find that white angle, if I knew that this arc was worth 80 degrees, and this arc here was worth 88 degrees.
So you add them up, 88 and 80, and then you divide by 2?
Mm-hmm. So you get 168 split in half. Would be 84. And if you look at the picture, you should be able to judge based on how it looks. If it's, does that look like it's a little bit less than 90 degrees?
Yes.
So, that's not always going to work out, but if you get a good look at the picture, you might be able to tell if it's if it looks right in the picture. Like if you got 168, or if you got 10 degrees, probably not good.
Yeah,
So
that wouldn't be right.
there's one other idea too. If I remember, there's at least one more idea with the angles that you should know, and that's when the angle is on the outside of the circle. And there's a formula for that outside angle. The formula looks a lot like for when the angle's on the inside. Do you remember the only difference between the two?
I don't remember, I really don't.
Okay, so there's only one small change, that instead of a plus sign and being in between,
B minus?
it's subtracting inside. There's a way to remember that too, for this picture at the top. If you've got two chords that intersect inside the circle, it sort of looks like what symbol?
No, a plus.
If you twist
sign.
it, yeah, it looks like a plus
Yeah.
sign. Someone might say it looks like a times symbol also, but
Yeah.
I mean that's just a way to remember that one there sort of looks like a plus sign. So
Yeah.
and that's one way to help you remember that one, for that one it's plus, and for this one it's minus. On the exam you don't get the formulas on the exam. You have to know
All right.
that those are the ones. So a neat idea I had here for this one, from the outside to help you see it better, is think about the angle as being like a mouth that's eating the arcs that are inside. So those are those blue teeth right there. And it's trying to chew on these two arcs that are inside, those green ones. So you'd have to know these two. If this was 60 degrees on the arc, and that was worth 10 degrees,
You have to subtract them and divide by 2.
right, so you'd subtract them to get 50. And divide by 2, so that's worth 25 degrees. And again, it looks like an acute angle. It looks like it would make sense.
Yeah.
This is good so far?
Mm-hmm.
How about one for you to try? How about this picture? I don't know how this is going to work out since I'm just working it out. By hand here. So let's see if this is 180 degrees here. They would never tell you that,
Mm-hmm.
but they would have to tell you that this is actually the center of the circle.
Okay.
So be on the lookout for semicircles. So that's 180 degrees. If this is 120 degrees for that arc, and I want to find this angle right here,
You're just making it complicated. Did you have to subtract 120 minus 180?
yep,
Is that, oh.
because I mean so sometimes they don't give you the pieces that you need. Sometimes you have to find the piece.
How
So-
would you do that? That's what I need.
All right, so this is the angle here, right? So think of that as being the mouth that's chewing on two arcs. It's chewing on this arc in yellow, right? The 120. It's also chewing on this arc here, which we don't know. But what do we know about half circles?
They're 180.
So if this part's 120, the other arc is going to be how much? What would it take to make it 180?
60.
60? So it's not labeled, but you have to hunt it down
Okay.
like that. So that's how they can make these questions just one step more complicated. So we got, so how much is that worth, angle X?
60.
What do we have to do with the two arcs that are in the mouth of the angle?
Oh, wait, you need to find the 60 and then you have to subtract. I'm so confused.
Okay, well, going back.
Oh, okay.
All right, so we will look back at the last example, and then Carolina's
So it
pretty
would be
good on this now.
60, 120 minus 60.
Yeah, it's always the big arc, take away the small
Yeah,
one,
and divide it by 2.
divide by 2,
I
so,
got you.
so 60.
I'm done.
And the answer doesn't look absolutely perfect, because I'm just freehanding it, but
Okay.
it looks reasonable that that's the right answer.
Okay.
That might just be just about it for angles. I mean, that was the most important stuff with the angles, I guess. I mean, there are some small ones, too, that you can stomp out without even having me around. Like, for example, if these two blue chords were the same, do you think that these two arcs would be different or the same? If the blues are the same, are the whites the same?
No, yes.
Well, look at the white.
Yes.
Look at that. Think of it like a worm or a snake or something. How long that white is. If those are both snakes,
So it'll be
do
yes.
they look the same?
Yes.
Yeah. So sometimes the questions can be very fast. Like if this is worth 100 degrees, how big is the other arc worth? It would be worth the
100.
same.
And would the inside be the same, or would it be half of it?
I'd have to draw the angle, and if I drew the angle in, then this angle would have to be half as much.
So it would be 50.
50.
Okay.
Yeah. And there's some other things too. I might be forgetting some smaller ideas with the angles too, but that's the most important
Alright.
stuff. So that's one half of the unit,
Oh.
and the other half of the unit is on the lengths too. So it's important not to get you won't get the ideas mixed up, because if you try to use the wrong formula, there just wouldn't be the right amount of pieces involved. So the good news for the lengths, though, there's really only, I think, 3 pictures or 4 pictures that you've got to be ready for. So let's start with this picture again, where you've got 2 chords that intersect. Of all the ones that we studied, I mean, I've got my favorites. This is probably my favorite. That if I know that that's 2, and that this is
Oh, I remember that.
all right. So so if that's 2 and this is 6, and this is 3, how much does the last part have to be worth?
Right.
What do you think? So I got 2 and 6. And I got 3 and blank. How much would that have to be worth? So I was calling it PP equals PP. PP. So and P for part. So what would the left side look like?
So, so
Yeah, it comes from cross multiplying, I guess, is how it goes. So what's one part? 2? What's the rest of it?
2 times 6 equals 3 times x.
Mm-hmm. So this one's 12 is 3x. Divide by 3. And you get x is 4. I think that's the coolest thing. Like,
Oh,
you tell. I mean, it's like
yeah.
it almost seems like, really, you're telling me that if I know that this is 3, I know that that's 2 and 6, that I can figure out this other one without even measuring. Yeah, but I don't. I mean, just like here's another one. Like, I don't know if I just think it's kind of remarkable, and it has to deal with the fact that the circle's very symmetric and a circle's a very perfect thing. But I mean, to me, it's crazy to think that if I knew that this was 6 and 4, and I knew this was 8, that I could find out how far it is in blue. And maybe without using a calculator, and maybe without even setting up an equation on the paper. So how much do these parts add up to or multiply to?
Wouldn't it be 3?
You're right. So what is 4? So he's got. So this part would have to be 3.
6 times 4 is 24. Divided by 8.
Yeah.
Oh.
Usually you would. I mean, why would you multiply? I mean, it's even the idea of thinking about that's kind of crazy. Like, this is 10 from here to here, right?
Mm-hmm.
But usually, I mean, if you're talking about this, it's important to know that's 10. But the cool thing is, if you multiply that, that's 24. And then 8 times what is also 24? 3. So, I mean, you can write an equation. You can write an equation out of it to keep track of everything. So it's part times part equals part times the rest of it.
Do you have to do part times part, or can you just do something else?
Like, do it in your head.
Yeah.
You should at least write down something on the exam. If it's multiple choice, you wouldn't have to show any work. But if it's a partial credit question,
Alright.
you might want to just write it out to get full credit, but also in case you make a small mistake at the end, you can get credit for what you wrote. So that's one of the ones with the other one is this picture again. but not the angle one. So,
Excellent.
so if this is 6 and this is 8, and this we don't know, and this is 9, there's a way to figure out the missing part. The formula that goes for this, I don't know, I mean, there's a lot of formulas so far. This, I think,
Yeah.
this is the last one, I think, that we actually studied. And the last one you have to know is, I was just calling this ow, ow.
Out.
Yeah.
Outside.
Outside.
with-
Outside, and the W would be the whole thing. Yeah.
So it'll be 6. 6 times 6.
6 times 8.
Nope, neither.
No.
Neither.
6 times 6 is the outside. What's the whole thing worth?
Oh, 6 and, oh, I get it, 14.
Yeah, so 6
Oh,
and 14.
6 times 14, and then
X and
For
then
the
X plus 9.
So you gotta keep that idea alive. It's the whole, it's the part times the whole,
and
the
then
outside part
X times 9x.
times the whole thing.
No, it's
X plus 9.
is it 9x?
No, it's X plus 9.
It's
Well, remember,
9x.
You gotta add them together, remember? So it's X plus 9.
yeah, the reason why it's X plus is because we're traveling through this and this. Don't confuse that with part times part equals part times part.
Okay.
If you did, you'd probably get an answer, it just wouldn't look right.
All
So that's one way to know that you're using the wrong formula. So this is the outside times the whole thing, the outside times the whole thing. And if I want to travel from here to here, it's not 9 times x long. Like if, let's say x was 5,
Mhm.
this wouldn't be
Okay.
5 times 9. This wouldn't be
It will be
that large. It would just be 5 plus the 9.
Okay.
So we don't know what it is, so it's just x plus 9. And I don't know if this one probably won't work out because I just slung the numbers together right off the bat. But that's what the setup would look like. And
So
then
you
keep
have
on
an x
going.
squared, and then you have
Right.
to do the t-chart.
Yeah, with the factoring, yeah.
All
So
right.
so 6 times 14 would be 24, and 6 would be 64, 84. So this one probably doesn't have a happy finish, but at least this is what it would look like. You're right, you'd get an x squared, you'd get a
Yeah.
quadratic equation, and then you'd
Plus
have to
9x.
get the 84 to the other side.
Mhm.
And I'm going to be a chicken and not try to finish this because I just have the idea in my head that this won't be a happy ending. I'd have to use a different formula to get the answer, but
Yeah.
you know, usually they'd work out where you could
Yeah.
factor it, so et cetera, et cetera.
Okay.
And you'd get a positive answer and a negative answer.
So you cross out the negative and the answer is
Right,
positive.
yeah.
Okay.
One more.
Okay.
One more, and I don't know if the bell's about to ring, but this,
It's not even close to ringing.
well, remember on that shortened bell schedule today too, so maybe,
Yeah, that's how you do it.
I don't know, my vision's not so good from this far across the room. So, yeah, here's one more that's a lot like that last one, but a little bit different. Oops, I gotta get rid of that. Ugh. Let's start again. So, on this one, if I have a secant and a tangent, it's going to be the same formula we just used, but the picture is slightly different.
Yes.
Because in the last one, there was a circle with 2 secants drawn through it. The good news is the rules still work for this picture where you've got a tangent and a secant. So if this was 4 and this was x, and from
That'd be
here to
4.
here was worth, let's say, 12, there's a way to figure out the x.
Okay, so it will be 4 times 4 plus x, right?
Right. So 4 times the whole thing, x plus 4. Or did you say 4 times?
No, x plus 4.
Oh, yeah, you're right, yep.
And
equals.
12
That's the outside.
times I don't know. 12 times, I don't know.
Well, what the pattern says, it's the outside
12 times 12?
times the whole thing. So,
Maybe.
you're right.
Oh, okay.
So when you've got that tangent, it's the same number repeated. Or if it's an x, you'd get two x's repeated. So, and then you would just finish with
And then
four
you do
x
the-
plus 16
okay.
with distributive property is 144. Now, this one probably will have a happy ending. 144 take away 16.
28.
Wait, oh, it's not even on. Okay, 144 minus 16. 128.
And then divide by 4.
You said 20.
That's 20 the ending.
Sure you did.
My pictures does not look right, but if you divide by 4, you get 32. There's no way that that's 32. It's just because
No.
my picture is really poor.
I get the point.
Yeah. You see why my picture's so poor? This is 4.
Mm-hmm.
Does this look like 12 if that's 4? It looks way less than 12.
Mm-hmm.
So, but that's how it gets done. Those are the big ideas. Yay.
Okay.
That was
This is
Carolina
all in
and Sean helping out with
Yeah.
the work. So good job. Good job. And there's the last circle, a little smiley face.